So, welcome back to our session on Mechanics 1. So, today we'll be discussing, as you can see, Newton's third law. Okay, so Newton's third law among us is such a popular statement, right? So, it says for every action, there is an equal and opposite reaction, right? So, why don't they cancel each other? They should be canceling each other, right? So, why don't they do that? So the thing is that action is on one body and reaction is on another. So this law basically says that you cannot have a single force. There cannot exist an isolated single force. Okay. So yeah, let's delve into the details. So there will always be an action reaction pair. Okay. So, suppose we have a plane like this onto which a body is kept, a block of mass m is kept onto the surface. Okay, if we are to mark the forces, there will be mg acting downwards and there will be n acting upwards, right? Mg downwards and n upwards, right? So can I call these two forces action reaction pair? Can I do that? The thing is that we cannot. Here, mgn is not an action reaction pair. Okay. If we look at it, we can see that, okay, they do have the same magnitude and they do act opposite to each other. It looks as if it obeys Newton's third law, right? But it is not an action reaction pair. Then what is an action reaction pair? Or why is it not an action reaction pair? Okay. So basically, the first thing that you have to notice here is that action and reaction acts on different bodies. Action and reaction acts on different bodies. Okay, so here when you look at it, these are two forces which are acted upon this body, be it mg or n. They are both acted upon this body, right? So action and reaction should be acting on different bodies. So this is not an action reaction pair. Okay, and the second thing is that they should be of the same nature. Action and reaction, there the pair should be of the same nature. That is what one cannot be electrostatic force and the other a gravitational force. Both should be of the same nature. Like if one is electrostatic force, action is electrostatic force, reaction should be an electrostatic force as well. Okay, that is, they should be of the same nature. Okay, here we can see that one is a normal reaction, one is a contact force, and the other one is a gravitational force. So that condition is also not obeyed here. Okay, and of course, forces always exist in pair. Forces exist in pair. Okay, if that is the statement, here we should be able to see the action reaction pairs, right? That is, this force cannot exist isolated, right? Neither does this force. So this reaction force, that is this normal reaction, should have a action or reaction pair, right? So let's split it and see what is happening here. One second. If you are to take the same case, say you have a surface here and the body is kept right here. Okay, it's touching it. Then there will be a normal reaction. We know that there will be a normal reaction acted upon the body by the surface, right? Say it has a value m. And then there will definitely be another normal reaction which is acted upon the surface by the block. Okay, so this one is basically the force that is applied by this body onto the surface. Okay, and the thing is that when you look at it, both the forces have the same magnitude and they act in opposite directions. Okay, so this you can, if you call this as action, you can call this one as reaction. Okay, and what about this one? What about mg1? Let's take that as well. So inclined plane again, sorry, plane again, and you keep the object right here, and there is force due to gravity that is acting downwards, right? Whose value will be m times g. Okay, and it acts directly. If this is earth, say this is earth, so mg is due to the earth, right? So the thing is that earth will, there will be a force applied onto the earth by this body. This force mg is acted upon the body by the earth. Okay, and the reaction force will be acted upon the earth by this body. Okay, and that will be in the opposite direction. Okay, and it will also have the same value mg. Okay, so here when you look at it, if we take this one to be action, this one is the reaction. Okay, and if you look at the three conditions, we can see that the three conditions are obeyed here, right? So that is it about Newton's third law. Okay. All right, then I think we can wrap it up now. And thank you for listening. Have a good day.